Welcome to the New Industrialists, a show where we explore innovation in mobility, energy, and manufacturing. I'm Adam Bogobovic, and I'll be your host through this series of conversations. And today I'm here with Evan Brennan, who's with Neural Concept, and he is on the GTM team for North America. Evan, it's so nice to have you on the show.
Nice to meet you, Adam. Thank you for having us.
Pleasure is all mine. It's an exciting place and moment in time. We're at CES, we're in Las Vegas, and I know you guys are making some amazing changes and building new technology. Not everybody may know about Neural Concept. Sure. Could you please tell us what it is that you do and what difference do you make to your customers?
Yeah, absolutely. So Neural Concept is a software platform that's bringing artificial intelligence to the core of modern engineering and product development workflows.
So that's a mouthful. That's
yes.
a lot of ideas
in
one. Okay, but what does it really mean? What does it mean that you bring software? What do you guys build? Do you build applications? Do you build AI?
Yes, so artificial intelligence is at the core of everything that we do. So the company is founded in 2019 in Switzerland, out of a research university there, EPFL. So our CEO and a couple of the co-founders were working in computer vision, developing artificial intelligence models for 3D structures. And then the software platform is an application of those models to engineering design, product design challenges.
So you're really deep into the engineering, into the innovation on the engineering side.
Absolutely.
Fascinating, especially when you're in CES and you look at all the innovation being discussed here. What is the big news that you're bringing, innovation you're bringing into the show here?
Well, there's a couple of things that are kind of bringing us into the show in terms of momentum. One was later last year, right at the end of 2025, we announced a Series C funding. So through Goldman Sachs in the US, $100 million Series C funding, so giving us that extra kind of momentum to grow this year and really validating our technology as needed in the market and giving us that growth potential into the future. We're also just today releasing some new features in the tool for kind of pre-release around engineering co-pilots, design co-pilots that are physics aware and geometry aware. So this is, again, really at the core of how modern engineers are designing components for your vehicles, your airplanes, your consumer electronics.
But that's a new way to think about engineering, because you're bringing the co-pilot, which is the broader concept of AI, into the engineering, cutting edge of technology. What does it really mean for customers to have the AI as part of their tool set?
Yeah, no, great question. So we can talk about the state of modern engineering right now and why artificial intelligence is required or why it's needed in these workflows. Currently, large major engineering organizations are using computational analysis to design every component you interact with. So they're simulating the physics of your vehicle as it drives down the road, as it crashes, your airplane in the air. All of these things are being simulated in a virtual environment. But that data is mostly used as a one-off simulation for that design, for that vehicle. And then the next time they kind of rebuild the model and they reuse it and they use methodologies that are consistent, but the actual data is deleted at some point. Bringing in artificial intelligence into that layer, into that digital ecosystem of engineering, allows the models themselves and these workflows that we are building to learn from all of that data. So over the course of time, you're developing smart workflows, intelligent workflows on top of this digital ecosystem to extract the insights and intuitions from what's already happening.
So that is a very different and new way of thinking about the problem set.
Right.
Are you unique in a way you approach it?
I think the uniqueness with Neural Concept is the fact that we are AI native. So there's many different software players in this simulation world. But Neural Concept is AI native, as I mentioned, coming out of sort of groundbreaking research. We were the first to market with these kinds of three-dimensional models. So AI models that learn from 3D space, that are spatially aware. And that gives us a foundation of understanding to apply to engineering challenges.
And you're getting recognition. You're already getting the level C funding.
Right, the funding is
correct. Is it based on the thinking that you already done, or is it based on the traction that you're getting with some of the customers?
Yeah, very much based on traction and growth potential.
Can you talk about what the traction looks like?
Yeah,
Can you share some?
Absolutely,
of it?
That's what we're very proud of at Neural Concept. It's not just about the potential for these solutions, but really bringing value to our customers today in engineering. So there's a lot, like I mentioned, about there's the long tail of benefit from leveraging AI that you're growing and learning from your engineering ecosystem and data that you're generating. But even today, we're bringing a lot of value with optimizations, exploring larger design spaces with predictive analytics, not sitting around and waiting for these larger physics models to solve, or even slower, waiting for prototypes to be tested and broken.
Are you able to engage with larger companies, larger OEMs with your ideas
absolutely.
and concepts?
So usually our main customers are large engineering organizations because they have this digital layer, this digital ecosystem pre-existing that we can then come on top of and build the sort of intelligence layer.
And how do you play with Microsoft? We are here, we have this incredible platform, computing platform in the cloud.
Right.
Are we part of the solution, part of what you are doing?
Absolutely. So we're a cloud native solution, and all of our software as a service applications are hosted on Microsoft Azure.
And how do you manage the interaction and the OEMs themselves? Like I know there's a lot of legacy tension for doing a lot of this work on premises.
Right.
There's a data security component. How you manage this with this concept of being in the cloud?
It's a moving landscape always with engineering tools. There's constantly new things coming up, and I think the momentum for the last decade or so has been towards something cloud native because these models get so large that on-premise storage is no longer viable. So having customers already shifting data structures and simulation structures to the cloud has helped us, where we can come and deploy right there on their Azure. So it may not be hosted on our software as a service, but it can be hosted on their Azure.
So you are following the leaders. You are not staying with the laggards.
Right.
Yeah.
Right.
Okay. I definitely as a somebody building new technology, it's
Absolutely.
a brilliant way.
Yeah, and in many cases, we're bringing their simulation workflows to these cloud environments. So where we want to sit is as close to the engineering data as possible, and we need to generate data to train these models. So if we can move simulation to the cloud and we can also be in the cloud, it's much more efficient than having to download and upload engineering data.
When you are pushing envelope, when you are pressing on something brand new that the customers are not yet familiar doing, you must be experiencing feedback from them and things that they do that you haven't expected. Can you tell me about some things you've done with your customers that you never thought they would do with your technology?
Absolutely. I think that's interesting and very, very cool for me personally to see these kinds of ideas and concepts sort of break containment in a way, where we're giving them a tool and kind of, usually at first there's quite a bit of training and upskilling. These types of machine learning, data science driven applications are unfamiliar to traditional engineers. So giving them those skills and then watching them grow into it. We've seen public cases from Mahle, for example, around fan blade design, where they're designing these fan blades, exploring new designs, new novel design spaces even that we wouldn't have thought of. We wouldn't have thought of to push them in that direction. And in that sense, they're doing what we want. We want our customers to learn the tool and then take it to new heights.
I love it. Every time I hear technology, I always, I'm an engineer. I want to hear how the technology actually plays out when the customers, put it into something that they do. So the blades are a really great example for me.
Exactly.
Any other examples like this? Something really tangible that you've seen?
External aerodynamics for vehicle design is a huge application for us. I think many OEMs globally, not just in Europe where we were founded, but here in America now, are leveraging data science and artificial intelligence to explore new concept vehicles and understand whether or not those are going to fit in their aerodynamic constraints.
And when you find them customers making, discovering what they can do with your technology, like the new aerodynamics, how big is that change? What does it mean? Is it like improving something by 0.5%, or is it fundamentally new way of doing something?
No, it's a fundamentally new way of thinking about engineering challenges and using these tools that they've been using as sort of validation in some small-scale explorations, and thinking about them as data generation tools for large-scale design explorations.
So folks listening to us, a lot of them are engineers, and they think about their skill set, what they already know. They're listening to you and thinking, can I use the same tool set? Can I engage? Do I have the right skills?
Yeah.
How do I get started? How would you respond to that? How would you guide somebody into being able to take advantage of what you are building?
Absolutely. I would say at first, reach out to us and we will get you the tools that you need to do that. What we're usually doing is working with customers to define the use cases that are ripe and ready for these kinds of applications, where you have the methodologies to generate the data to train the models, and we will bring you the skills. We'll train you on the platform. We've been doing a series of global boot camps for the past few years, where I think just this past year in 2025, we had over 300 different simulation engineers, data scientists come into our rooms in San Francisco and Detroit and Germany, in Japan and Korea, and meet with us for multiple days, train on the platform, get to know other customers, competitors of theirs that are using the same platforms, understand the benefits and how to use it, and take that back to their organizations to apply.
And for somebody to come to one of these boot camps with you, what skill level do you have to have to be able to be be able to take advantage of it? Do you have to be a data engineer, data
no,
scientist?
absolutely not. The fundamental knowledge you need to have is your domain expertise in your engineering domain, and we will bring you along the machine learning and data science knowledge and help you upskill in that area. The foundational knowledge of the engineering problem is what you bring to the table.
For an engineer to engage with you and be part of the journey that you are creating for them, what's the easiest way for engineers to come and engage with you? What type of skills and engagement and tools do they need to have to be successful by being part of this AI journey?
Fundamentally, you need to understand your engineering challenges very well and have an openness to approach the problem in a new way. So an openness to learn something new that may challenge your understanding of your problem, but will help you to learn a new methodology to apply.
When folks come to your workshops, do you get very young engineers out of universities? Do you get folks with 30 years or 40 years experience in engineering? Who's working with you?
It's quite a mix of both. I mean, you imagine these large engineering organizations have a lot of these people that have been there for 20, 30 years building expertise, building the methodologies that we are now kind of building on top of, building artificial intelligence layers on top of the digital layer. So it's quite a mix of both. The workshops definitely have some younger engineers that come out with Python knowledge, that come out having a master's degree in machine learning or something like this. Those types of profiles are very aggressive in the uptake, but the seasoned engineers understand the problems very, very well, and the intricacies of how to implement that solution is really important. It's not fundamentally about training the model. Training the model is well known, and we know that works. We know that these types of predictive analytics can help speed things up. But how to integrate that in a very complex engineering ecosystem requires that kind of know-how you can only get from 30 years of experience.
So you need both. You need to understand the processes, and you need to understand
technology
a bit
itself.
of the technology. Yeah. Yes. Okay, that's a fascinating story. How do you think about? So now you're focusing on the automotive portion of the business.
Yeah.
How do you see your business moving forward? Are you going to stay focused on automotive? Are you looking for other opportunities to implement your technology?
No, we're seeing a lot of growth in the consumer electronics space, a lot of different cooling applications and even in circuit board design and layout, where there's a lot of visual aspects and multiple layers that these 3D spatially aware models can build a lot of efficiencies. Consumer electronics is growing quite rapidly. Certainly automotive will continue to drive our business significantly, but consumer electronics, printed circuit board analysis and design, and aerospace will certainly come along quickly.
So CES looks like a perfect event for you because you can touch on the mobility. You can open it up to all the other areas. Since you are dealing with such a complex, engineering problem that you're solving for, I would love to understand, what do you find the most difficult? What are the barriers and frictions you are seeing?
Yeah, as I mentioned already, there's a lot of momentum and pride, rightfully so, around these complex engineering workflows that they've spent the better part of the last 50 years developing, right? From these solver technologies, these physics-based solver technologies have been around for quite some time, and these organizations are very mature and very proud of those processes. So it's important to work with our customers and emphasize that we're building on top of that. We're not replacing that at all. It's still there as an under layer and as a validation layer to these artificial intelligence technologies on top of it, but there's still a lot of momentum to stick with the status quo, right? And we're coming in with a fundamental shift in how you do your engineering work, which is at the core of these organizations' intellectual property. How our customers are designing their vehicles, designing their electronics is ultimately what they're delivering to the market, and we're asking them to let us into that world and show them a new way. So there's a lot of momentum to get over.
And clearly a lot of them are open, otherwise you wouldn't be running business, you wouldn't be having so many people coming to your workshops. What is opening the door? What is the driving function for them to engage? Is it the technology? Is it the promise of technology? Or is it the market dynamics that's prompting engineers to rethink how they've been working for so many years?
Yeah, I think more so the latter. I think there's a lot of pressure, especially in my domain in automotive, to get to market faster, to move things along the line quicker, to consolidate portfolios and be more dynamic and agile. And in that domain, these traditional solvers are just too slow to react. And so the process needs to change. So we're seeing a lot of companies coming to us saying, we know these technologies can be disruptive, help us to implement them effectively.
Congratulations on finding this amazing problem to solve. What is going to be next for you? What does the next couple of years look like for your company?
Yeah, as I mentioned today, we were just releasing this conceptual video around these physics-aware design co-pilots, AI design co-pilots. And at a high level, what this is allowing the engineer themselves to interact with the artificial intelligence in a human-in-the-loop way. So it's not a black box, not a magic system that says, here's your best vehicle design. It's interacting within the constraints of your engineering ecosystem and allowing the human to guide the design in their intelligent way. Ultimately, the engineer is guiding the algorithms here, is guiding the artificial intelligence to the proper answer and coming to a solution.
So you're building layers on top of the layers of the
Right.
intelligence that you're building the system.
Yeah.
Absolutely
And these
fascinating.
become these sort of agentic layers that you hear
Yep.
talked about, right? Where now you are integrating, you're interacting with the model in a language interface instead of interacting with it in a code interface or something like this. So this is the shift you'll see from our product in the coming year, is away from manual coding, manual building of these sort of pipelines and workflows to something like an LLM integration where you can ask for it and it'll develop for you.
Thank you so much. This was an absolutely fascinating conversation. Thank you so much for being on the show. I'm looking forward to watching how your company is going to develop this solution going forward.
Thank you for having me.